Yeah, good morning all. Welcome to my YouTube channel. In this video, I will be discussing on one of the important topic in cryptography and network security, that is the Chinese remainder theorem. So let's understand this Chinese remainder theorem by taking one example. Okay. So Chinese remainder theorem states that, or it is used to solve a set of different congruent equations with one variable but different modulo, which are relatively prime as shown below. Here you can see there are different congruent equations like A1 mod M1, A2 mod M2, like that, AN mod NN, but all are having the same variable, that is X, which are relatively congruent to all the equations, and those are relatively prime to each other. So finally I want to say Chinese remainder theorem states that the above equations have a unique solution of the modulo which are relatively prime. For example, here the x is there, no, that x will always be equal to this a1 m1 m1 square plus a2 m2 m2 inverse plus an mn m1 inverse mod n. It means that we need to find the x, one of the variable. That x or that variable will always be congruent to all the equations that we have here. Like x is congruent to a1 mod m1, x is congruent to a2 mod m2. So let's see a small example how to find this variable x using Chinese remainder theorem. Okay. So this is one of the example to understand. So here is the equation, like x is congruent to 2 mod 3, x is congruent to 3 mod 5, and x is congruent to 2 mod 7. So the same format what we have here. But we need to find that variable x using this Chinese remainder theorem. Okay. So how to find this x? Let's see. So here is the solution. So as I already told you, this x is always equal to a1 m1 m1 inverse plus a2 m2 m2 inverse, like that, a1 m1 m1 inverse mod m. So let us find this. So in this equation, if you see x is equal to a mod m, so this is nothing but a1 m1, a2 m2, and a3 m3. Okay, these are the values we have: a1 a2 a3 and m1 m2 m3. So a1 is 2, a2 is 3, a3 is 2, and also m1 is 3, m2 is 5, and m3 is 7. Now we need to find capital M1, M2, M3, and also M1 inverse, M2 inverse, and M3 inverse. Once we got all the values now, we need to apply this formula to get our variable x. Okay, let's see how to find those variables. So in the equation we have seen that we got a1 is 2, a2 is 3, and a3 is 2, and also m1 is 3, m2 is 5, and m3 is 7. So now we need to find capital M1, capital M2, and m3. Similarly, m1 inverse, m2 inverse, m3 inverse, because we need all these values in the equation. Along with that, we need even m also, capital M, okay, in order to do mod. So this one m. So all these values we need to find. Okay. Now let us see how to find these values. So how to find capital M? So capital M is nothing but m1 into m2 into m3, small m. So already we have m1, m2, m3. Just multiply it. 3 into 5 into 7, we got 105. So the capital M is 105. Now let us find M1, M2, M3, capital M1, M2, M3. So M1 is nothing but capital M divided by M1, small m1. So we have capital M is 105 divided by M1 is 3, where we got M1 is 35. Similarly, we will find the M2 using the same equation, we will get 21. Similarly, capital M3 we got 15. So now we got M1, M2, M3. M1 is nothing but 35. M2 is nothing but 21, and M3 is nothing but 15, and we got capital M is nothing but 105. So we are left with now M1 inverse, M2 inverse, and M3 inverse. So we have one formula known as M1 into M1 inverse is nothing but 1 mod M1. Okay, already we know M1, that is 35. Okay, so 35 into M1 inverse equal to 1 mod 3. So now we need to substitute the values from 1. If you take 1 here, m1 inverse, 35 into 1 is 35. So 35 is equal to 1 mod 3, Means when you divide 35 with 3, you will get 3 times 30 or 11 3 is 33. We will get 2 more 3. So we should get 1 more 3. Remainder should be 1. So if you take 2, 35 into 2 is 90. So 90 mod 3. If you do, remainder surely will get 1. So for m1 35, the m1 inverse is at about 2. So when we multiply m1 inverse with m, so and if you do mod operation with 3, we should get the remainder as 1. Such value we need to assume. So here m1 inverse is 2 because 90 mod 3 is 2 only. Sorry, 70 will get 70 mod 3 is 2. Similarly, m2 into m2 inverse is 1 mod 2 1. Already we have m2 is 21. Then start assuming values from 1. 21 into 1 is 21. So 21 mod 5 is 5 4 is 20. It is 1 is the remainder. So we can conclude m2 inverse is 1. Similarly, m3 into m3 inverse. Okay, 1 mod 7 will get. So again, let's assume 1. 15 will get 15 mod 7 is 7 to the 14 is remainder is 1. So m3 inverse is 1. So I assume any value, this inverse. So once you multiply that inverse value with the m value, and if you do mod operation with the variable m2, then you should get the remainder is 1. Such value we need to assume. So in this way you will get m1 inverse, m2 inverse and m3 inverse. So here m1 inverse is 2, m2 inverse is 1 and m3 inverse is 1. So now we got all the values. Just to substitute all these values here. Okay. So here I have done that. So a1 is 2, m1 is 35, inverse is 2. Similarly a2, if you do mod 105, you will get 233 mod 105. Just divide, you will get x is equals to 23. So this is what the variable x23. That's what we have defined in the statement. There may be different congruent equations, but we have only one variable. Okay, that's what 23 we got. So if you see this 23 here, so 23 is congruent to 2 mod 3, yes, because 23 mod 3 if you do, you should get the remainder as 2. So 23 mod 3 is how much? 3 7 is 21. So 2 is the remainder, yes, it's satisfied. Similarly, 23 is congruent to 3 mod 5, yes, 5 4 is 20, 3 is the remainder, yes, it's also satisfied. Then 20c is congruent to 2 mod 7, yes, 7 3 is 21, so 2 is the remainder, so it is also satisfied. So the variable x is nothing but 23, which satisfies all the congruency of the given values in the equation. So hence it is proved that 23 is the x value using this Chinese remainders theorem. So hope you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.